Imagine a machine that could see diseases before they ever show symptoms. A scanner so powerful, it doesn't just take pictures of your organs, it maps the quantum behavior of your molecules in real time. This isn't science fiction, it's the vision of quantum MRI. Today, we'll explore how conventional MRI works, what quantum physics has to do with imaging the human body, and how quantum MRI could revolutionize medicine forever. Before we get too deep into this topic, hit that like button and subscribe to the channel. This will help bring the truth about health and healing to the thousands of people who need to hear this message. Now back to the episode. Magnetic resonance imaging, or MRI, is one of the most incredible tools in modern medicine. Unlike X-rays or CT scans, MRI doesn't use harmful radiation. Instead, it uses magnetic fields and radio waves to peer inside the body. Here's the simplified version. Every atom has a nucleus. The nucleus of hydrogen, one of the most abundant atoms in the human body, acts like a tiny bar magnet. In an MRI machine, a strong magnetic field aligns these hydrogen nuclei. Radio pulses then knock them out of alignment. As they relax back, they release signals which the machine translates into detailed images of tissues, organs, and even blood flow. That's why MRIs are so powerful. They give us stunning structural images without cutting the body open. But here's the catch: they're limited. Standard MRIs show anatomy, not molecular activity. They're amazing at detecting tumors, injuries, and structural abnormalities, but by the time something appears on a scan, the disease has often already developed. For example, cancer might only become visible when a tumor has grown large enough to alter tissue density. Neurodegenerative diseases like Alzheimer's may only reveal themselves after neurons have been damaged. In other words, MRI is reactive, not proactive. It waits until damage has already occurred. But what if we could look deeper, down to the quantum level? This is where quantum physics changes the game. At the quantum level, particles don't behave like solid billiard balls. They act like waves, existing in states of superposition and entanglement. Quantum MRI aims to exploit these properties using ultrasensitive quantum sensors that can detect magnetic fields at the scale of individual molecules or even single neurons firing in the brain. Instead of just seeing the shape of an organ, we could see its chemistry. Instead of spotting a tumor once it forms, we could detect the very first molecular missteps that might lead to cancer. Here's the comparison in simple terms. Standard MRI works at the level of hydrogen atoms, produces structural images, limited sensitivity, can't see individual molecules. Quantum MRI uses quantum sensors such as NV centers in diamonds or superconducting quantum circuits, detects incredibly weak magnetic signals, even from a single proton or electron spin, can map chemical reactions and cellular processes in real time. Imagine diagnosing Parkinson's disease years before tremors begin, or tracking metabolic pathways in cancer cells while they're still invisible to standard scans. Quantum MRI transforms imaging from snapshots into movies of life at the molecular level. The implications are staggering. Early cancer detection. Quantum MRI could spot the very first rogue cell before it multiplies. Neurological insight. Instead of waiting for brain shrinkage to diagnose Alzheimer's, doctors could track neurotransmitter activity decades earlier. Personalized medicine. By seeing how drugs interact with cells in real time, physicians could tailor treatments for each individual. Preventive healthcare. Instead of reacting to disease, medicine could focus on stopping it before it begins. Quantum MRI doesn't just improve medicine, it could transform it, moving us from repair to prevention. Of course, the road isn't simple. Quantum MRI technology is still in its infancy. building stable quantum sensors, shielding them from environmental noise, and scaling the machines for hospitals are huge challenges. Right now, most prototypes work only in research labs, but so did the first MRI machines in the 1970s. Today, MRIs are everywhere. The same trajectory could apply to quantum MRI. So, what's the takeaway? Standard MRI gave us eyes into the body's structure. Quantum MRI promises eyes into the body's secrets. It merges physics and medicine, turning quantum theory into quantum healing. We may be standing at the dawn of a medical revolution where disease is caught before it begins, and where diagnosis is as precise as the quantum world itself. And that's the future of quantum MRI. If you enjoyed this journey into the intersection of quantum physics and medicine, hit that like button, subscribe for more deep dives into science and health, and share this video with someone who's as curious as you are. For more information about our clinic, please go to drvictoriamunoz.com or see link in description below. We have helped thousands of people with prevention, early detection, and effective treatment of disease. Leave me a comment. What next big topic would you like to learn about? I am Dr. Victoria Munoz. Until next time, take care.